Okay, so today I will be telling you about our product called Visual Flow, powered by Apache Spark. We'll cover the following questions. What is Visual Flow? How can Visual Flow be used in your project? How did we come up with Visual Flow? How quickly can I develop a basic ETL job in Visual Flow? How does Visual Flow work? What data sources are supported by Visual Flow? What user roles are available in Visual Flow? How can I manage user-defined parameters in Visual Flow? What does Visual Flow IDE look like? How do I create pipelines in Visual Flow? What does Visual Flow development roadmap looks like? And finally, how do I create my first ETL job in Visual Flow? All right, so Visual Flow is a cloud-native ETL tool with UI. It combines the best features of Kubernetes, Spark, and Argo workflows, such as portability, flexibility, multi-cloud compatibility, development efficiency, high availability, performance and fault tolerance, low cost, and open source code. So in the modern data-centered cloud infrastructure, Visual Flow can be used to automate ETL tasks in a variety of scenarios, such as transferring data from transactional data sources and flat files from network file systems to the data lake, transforming and cleansing the data within the data lake, transferring data from the data lake to the data warehouse, transforming the data within the data warehouse to fulfill the needs of the data analytics tools. The Visual Flow project was started in early 2020 by a group of 6 developers, some of whom had previously worked in a large-scale data engineering project, utilizing the same core tools that ended up constituting Visual Flow. Their goal was to create a solution that could help to do their routine work easier, faster, with less mistakes and less people involved. At that time, other Visual Spark ETL tools had already been emerging on the market for a while, but they seemed to always be either costly or too tightly integrated in their proprietary platforms, thus requiring too much of a paradigm shift for the project. So our developers saw Visual Flow as a lightweight, easy to get open source solution that would nicely complement an already existing cloud or on-premises environment with little to no change in the infrastructure. With their ETL background, the developers knew well that switching from traditional ETL tools to Spark ETL may be harsh. While offering great flexibility, scalability, and unlimited parallelism, both Spark and Kubernetes demand significant programming, deployment, and configuration skills. Before one can dive into creating and running their first Spark jobs, there's a need to know Python or Scala or Java, a build tool such as SBT or Maven, a workflow orchestration tool such as Apache Workflow, and those instruments have a rather long learning curve. Traditional ETL tools, on the other hand, do not require knowledge of a programming language. Most of the designer palette is self-explanatory, and the build and deployment processes are hassle-free. In addition, they come with built-in monitoring, alerting, and error handling tools. With that traditional ETL mindset, Visual Flow was created. To illustrate the benefits of using Visual Flow for accelerated ETL development, we've carried out an experiment during which the same functionality was implemented manually in Scala and using Visual Flow, a simple ETL job that extracts data out of one S3 bucket, applies grouping and filtering, and records the result to another S3 bucket. That is really a basic ETL job, but such basic jobs constitute over 50% of the typical integration project. The manual implementation required a whole bunch of tools: Scala, Scala IDE, Apache Spark, Scala Test, Airflow, Maven, Jenkins, whereas Visual Flow already includes everything you need. It took us only 15 minutes to build our ETL job in Visual Flow and a whopping 2 hours to achieve the same using the manual tools. The difference may add up to a staggering number at the project level. So Visual Flow is based on Argo workflows, which is an open source container native workflow engine for orchestrating parallel jobs in Kubernetes. Argo workflows is implemented as a Kubernetes CRD. So here's how Visual Flow works. First, users create jobs and pipelines in the UI. Then the jobs and pipelines are stored as config maps and workflow templates in the Kubernetes namespace. Then users trigger pipelines manually or define run schedules. And then Visual Flow creates an instance of each workflow from a template. Then Argo launches each workflow in a separate pod. Spark jobs are executed as tasks in separate pods as well. And finally, Argo sends a notification to the Slack channel should any of the tasks fail. Since Visual Flow uses Spark to operate on data, it can support any type of data source that is supported by Spark itself, but the current UI's choice is limited to Amazon S3, IBM Cloud Object Storage, Elasticsearch, and DB2, with more data sources to be added in the future. And I will touch on it briefly on the roadmap slide. Visual Flow specializes in Spark jobs creation and management and offers an easy-to-use IDE. One does not need a database to set up Visual Flow. All the configuration is stored in Kubernetes as config maps. All you need is a Kubernetes cluster. Visual Flow has built-in user role management, wherein users can have one of the following roles. A super user can create projects and manage them. An admin can manage access within projects. An editor can create, delete, and modify jobs and pipelines. An operator can run and stop jobs and pipelines. A viewer can monitor execution of jobs and pipelines. The user directories supported are those of GitHub and GitLab. The upper level entity in Visual Flow is a project. All the roles except for super user apply at the project level. Each project may have a set of user-defined attributes associated with it that can be accessed in the project's jobs and pipelines. The examples of such attributes are database connection information and email addresses of an alert's recipients. Visual Flow is a multi-tenant system. That means one can create multiple projects on a single cluster. Each of the projects manages the resource allocation and user access in its own namespace. As in most traditional ETL IDEs, in Visual Flow you design jobs by dragging boxes, aka stages or processing nodes, from the palette onto the job canvas and then connecting them together with arrows. Users can choose from one of the available stages: read, write, join, union, filter, group by, remove duplicates, transformer, and change data capture stage. All of these stages but one are configured using a set of property fields. The transformer stage will require the use of SQL and is intended for user-defined transformation logic, which is anything that is not covered by the other stages. Visual Flow supports job chaining. A group of chained jobs is called a pipeline. Designing the pipelines is straightforward using drag and drop operations in Pipeline Designer, where you can also set up alerts. The alerts use Slack, the popular corporate communication platform. The job and pipeline statuses can be monitored on the corresponding screens in the UI alongside the CPU and memory utilization. The jobs and pipelines can be exported for code backups, migrations, and promotions. While we have made Visual Flow available to the public, we acknowledge its shortcomings, and we want to make it more versatile and user-friendly. Already, the following changes are included in our backlog. So currently, only standard Java logs are available, which are verbose and maybe overwhelming for those who just want to see where their job has failed. For that reason, we want to add a new level of logs with very basic information that can also be included in email notifications. We are adding a driver manager at the project level to allow users to choose from one of the prepackaged JDBC drivers as well as add their own to work with their data sources. In case you want to use a data source not natively supported by Visual Flow, such as REST API, we will be introducing a new stage for calling external applications in your ETL jobs. Currently, only Slack can be used to send out notifications. Naturally, we want to extend that to emails and allow the users to easily include job logs in them. Cron scheduling is currently not possible in the UI, and we will add it. If you call an external routine in your ETL job, you may want to reuse its output in the flow, but then you need to persist it somewhere. To help with that, we will be adding support for persistent volumes. And finally, Spark on Kubernetes is great for larger workloads. But what if you have a lot of smaller ETL jobs that only do light lifting day by day? You may not want to spin up a cluster each time you run each of those jobs, because a simple Python script could accomplish the task in a matter of a couple of seconds. We're looking into allowing our users to run their smaller ETL jobs fast by simply changing the execution environment. So to summarize the information, Visual Flow helps you to kickstart your cloud ETL journey using an intuitive and concise user interface. It can run on any kind of Kubernetes cluster in cloud or on premises. It can be set up and ready to go in less than 13 minutes. It doesn't require knowledge of any programming, build, deployment, workflow, orchestration instruments. It helps to quickly design applications to move and transform large-scale, semi-structured data sets and load them into data lakes and data warehouses by combining the ease of use of transactional ETL tools and the power and flexibility of the Spark processing engine. If you have any questions left after this session, or you would like to try Visual Flow on your own in your own environment, please visit the products page on the screen. Also, feel free to reach out to me directly. Visual Flow is also available on GitHub, AWS, and Docker Hub. All right, and finally, to conclude this presentation, I'm going to do a small demo to show you what Visual Flow feels like when you create a fairly basic ETL job in it. We decided that more complex ETL jobs were not a good fit for this presentation, but we'll be uploading some to our YouTube channel. Okay, I'm gonna stop the slides now. All right. And so, well, basically, look. So the test job is gonna use two CSV files. All right. So those CSV files have some flight schedules in them, only 9 records each. And now our test job is gonna pull those files and then just combine the information and insert the data into a DB2 on cloud table. Okay. So let's start with the files. Let's upload them to S3. Okay. So here are the files. Let's check them out. Some flight schedules here and here. Right, so let's upload those. Okay, so here's the target table in DB2 on cloud. So currently it's empty. The format is the same as of the files, as you can see. All right, so now let's move on to Visual Flow. So here's what it looks like, the landing page. Here I choose my project. We already have several projects created. We choose demo project 1. Okay. So here you can see jobs, pipelines, import, and settings. Let's go to settings and parameters. So at this level, you can specify your shared parameters to be used in multiple jobs in your project, so you don't have to specify the same parameters here and there. Okay, I have already entered several parameters, connection parameters to be used by our test job. So let's go ahead and create a job. I go to jobs. Okay, just by the way, let's delete this one. Yes. Okay. Add job. Let's call it S3. Oops. S3 to DB2 demo. Here we can specify Spark cluster parameters. I'm not going to touch them for this test. I just click confirm, save, and here we are. So on the left hand side you can see the stages, the designer palette. I'm gonna drag and drop the stages I'm gonna need for the job. 2 read stages for the CSV files, a union stage, and a write stage. Okay, and now all is left is to configure each of the stages individually. Let's just do that. Give it a meaningful name, choose the storage type, and then just look up the parameters, connection parameters from the project level. So I'm going to choose server, the authentication type, and the access key, and the secret key. That's the buddy. Okay. And the bucket. Okay. Path and bucket. File format is CSV. We have a header and the delimiter is comma. It's 3 secret access confirm. The same with the other source. Storage. Server. The authentication type. Access key. Secret key. Bucket. Path. Short CSV. File format. All right. Header is true. The limiter is comma. Confirm. Now we connect those stages to the union stage. This, and configure the union stage. Give it a name. Choose the mode. All values, either all values or distinct values. I choose all values. Connect it to the right stage. And one stage left. Call it DB2 out. The storage type is DB2. Obviously, the URL user is here. There's the password. Schema is the same as the user. Okay, the table is called flight. Write mode is override. And confirm. Okay, let's double check everything. Looks good. Secret bucket. And it looks good. This one looks good too. Okay, the union stage. Okay, once again. Confirm. DB2 out. Okay. Good. Good. That's it. So we click save. Now our job is saved. Let's go back to the job list. So from here we can go back to the job. If we click the job designer button, we can also check the logs. Right now we have done, but there will be here once we run the job. So let's get back to the designer. Check again that everything is okay. Seems good. Seems good. All right. Time to run it. Hit the run button. And now we're just gonna wait 1 minute because Visual Flow needs to create the infrastructure to run the job, which right now is an overkill for such a small job, but this is just a demo for demo purposes. So in our case, the resources, the infrastructure creation is going to take 99% of the time, and running of the job itself is going to only take a couple seconds. But I think it shouldn't take more than 1 minute overall, so bear with me. Okay, so it has succeeded, and now let's check the target table. It was empty. Now I hit refresh, and the records are here. Yeah, so that's it. That was a really basic job, like I said, but at least in my experience in the project I have worked in, even such basic jobs, they constitute more than 50% of the overall workload. So you still have to do them somewhere. Okay, so now it's the time for the Q&A session. I'm gonna go back here. Well, actually, no. I'm gonna show you the contact slide, this one. So you guys can see the URL. So you can reach out to us after the session with your questions, or you can email to me directly. And please, if you have any questions, go ahead and ask them. I'll try to answer. If I can't, Ivan will do the same. I'll give you a couple more minutes, and then if no questions, we can wrap it up. And thanks for joining us. Hope you learned something new, and maybe you will want to try our product out. Stop sharing now.
Seems like your presentation was very clear.
All right.
No questions. We have
That's
no
not
questions.
so bad.
Wait. Yes, we have one question.
Go ahead. Shoot.
Question is about when exactly people can try Visual Flow.
Where do you see those questions? In the chat? I don't see that.
Q&A, question and answers.
Oh, let me see that. Okay. So you can check Visual Flow on our, so that URL I was sharing, you can go there and go all the links from there. So this, it will basically lead you to GitHub, AWS, and Docker Hub. So that's it. Or you can just Google Visual Flow and find the locations. I think it should work too.
It's also available on Amazon, right?
Yeah, AWS, exactly.
Yes.
Also have pretty good instruction on how to install it. All right, guys, I guess that's it. And thank you for joining us, and have a great rest of the day. We'll wrap it up. Thank you. Bye, Ivan.
Bye.